Okay. The function f of x equals x minus 3 times x minus 5 times x plus 4. You're asked to verify if x is to the left of negative 4, whether this function is, that the function is always either positive or always either negative. And either that or something very similar to it. I don't remember exactly how it was phrased, but that's the essence of what we're doing. So, first of all, put this in context. We understand that the zeros of this function are at negative 4, 3, and 5. So if you look at our graph, negative 4, 3, and 5 are going to be zeros, so our graph is going to have to go through these 3 points. We want to determine if x is to the left of negative 4, what the sign of the y value will be, whether it's positive or negative. Now, if x is less than negative 4, well then x minus 3 is less than negative 4 minus 3. If x is less than negative 4, if we subtract 3 from both sides of this, this is what we get. Okay? Or if we say x minus 3, well, since x is less than 4, then x minus 3 will have to be less than negative 4 minus 3. And that's negative 7, which is certainly negative. X minus 5, well, you do the same thing. You find that that's got to be less than negative 8. And x plus 4 is less than negative 4 plus 4, and that's 0. So x plus 4 is less than 0. So all these are less than 0. They're all negative, so when we multiply them together, we get a negative. Meaning that to the left of x equals negative 4, all our values are going to be below the x-axis. All our points are going to be below the x-axis. So when I drew it, I knew to come up from the negative numbers before I hit the 4, negative 4. Okay? Then, similarly, if x is bigger than 5, then x minus 3 is bigger than 2, x plus 5 is bigger than 0, x plus 4 is bigger than 9. You can easily verify this. So all 3 factors, and I didn't put an S on factors, so let's just go ahead and try to be grammatical. All 3 factors are positive. That is, this is positive, this is positive, this is positive. So when we multiply them together, we get a positive. So the graph has to be above the axis out here to the right of x equals 5 for x values greater than 5. Now we have most of the evidence we need to draw the picture of this graph. We have to go through this point, we have to go through this point, we have to go through this point. After going through this point, our values have to remain positive. Before going through this point, our values have to be negative, because of what we did here. Also, of course, we evaluate the y-intercept. Okay? Now, we're still a little bit slow about the fact that the y-intercept occurs when x equals 0. Make sure you understand that. Many of you do, but it looks like many people don't either. If x is 0, we get negative 3 times negative 5 times 4. And that's 60. So the y-intercept is at 0, 60. Now, we know that between negative 4 and 3, the y value has to be positive, because this point lies between the negative 4 and positive 3 points. And there's no way for the curve to get across the x-axis without going through a 0. So if the curve is positive here, it can't go through the x-axis at least until it gets to here. And if we go to the left, it can't go through the x-axis at least until it gets to here. Meaning it's got to stay above the x-axis. Since it's above here, it's got to stay above. If it was below the x-axis, it would have to stay below, at least until it got to here and to here. Okay? Now all this is nice and consistent. Below the axis, above the axis, so we come up from here, we get to go through this point, we come down here, we come back up through here, and there is a reasonable facsimile of our graph. Okay. Now ignore this. You now do the same, got x squared. That's from multivariable calculus. We just stick with this. Okay, we're going to look at a couple more examples.